Hi everyone and welcome to this breakout session. I hope you're enjoying so far. Today on this particular session is going to be a technical one. So we're going to be deep diving into how you can build out a sophisticated alerting system on Looker. So we're not using the alerting feature that's built in. We're actually going a lot deeper, a lot more sophistication there, and we're building that out with LookML. So I'm Jamie Fry. I lead the Looker practice at Datatonic. We're a long-standing Looker and Google Cloud partner based in the UK, Switzerland, and Sweden. And here with me is Ben Powis, who's from M&M Direct, another long-standing Looker customer. And Ben gets involved in all sorts of cool stuff. Data science, they run a lot of machine learning pipelines. They use Looker for all their analytics and self-service needs. And there's a lot of data engineering and cool stuff that they do as well. I'll let Ben introduce M&M Direct. But the agenda for today will be, Ben will take you through the journey that they've had with Looker and how they utilize it throughout their organization. Then I will do a bit of a deep dive into the alerting solution that we've built, and it will be quite a sophisticated tech demo. So this is very much for people who are looking to see how they can use Looker in a bit more sophisticated way, how they can expand their uses of Looker. If you're new to Looker, this will be interesting, but you might get lost during some of the technical demos. But I will now pass on to Ben, who can introduce M&M Direct.
Thanks, Jamie, and hi everyone. So my name's Ben. I head up the data science team at M&M Direct, and we're here today to talk about the alerting system that we work with Datatonic on. Before I go into that, I just want to give a bit of background on M&M for those of you who aren't familiar with us and what we do. So M&M Direct have been trading for over 30 years. We're an online off-price fashion retailer. We sell some of the biggest brands in clothing and footwear to customers directly at big discounts. We started as a catalogue retailer, so over 30 years ago. And for many years, the catalogue was our shop window. We would print physical catalogues and post them out to our customers who would phone us up to place their orders. And that was the only way they could order from us. We now have over 3 million active customers, actually a milestone that we passed in the last few weeks, so a really kind of exciting landmark for the business. We have a core business in the UK, but we do sell throughout Europe. We have 7 localized websites in European markets like France and Germany, and we ship to countries all over Europe. To give you an idea of the scale of mnmdirect.com, the website gets over 100 million visits per year. We sell over 300 brands in any given year at M&M. So as mentioned, some of the biggest brands that you would know from clothing and footwear. We send over 400 million emails out to our customers every year. And on mnmdirect.com alone, we show over 600 million pages of product every year. So I mentioned that we started as a catalog business over 30 years ago. Actually, about 5 years ago, we sent our final catalog and we decided to stop printing catalogs and refocus our marketing efforts into digital customer acquisition and digital customer experiences. So today, the only way you can order through M&M Direct is through one of our websites. What that means from a data perspective is that we get some data on every interaction our customers make with us, whether that's a visit to one of the websites or an order. We get to see, our customers are telling us what they like to interact with, what they like to buy. Whereas if someone is flicking through a catalog, it's much harder to derive that kind of information. In terms of our data journey, if we look back at the time we sent our final catalog 5 years ago, our data looked very much like this slide you see in front of you. So a typical kind of siloed data environment. We had on-site engagement data in one place. We had product stock information in another. We had different teams working on these data silos, and they were all experts in their own particular area of data, but there was no way to join it all up and paint a kind of full picture of the M&M experience that our customers were getting. What that meant from an analytics and reporting perspective, you can see in this slide. So we had situations where a couple of analysts might be asked the same question and they could return different answers by getting different data from different data sources. This is obviously quite frustrating. We want everybody to be working from the same data and certainly to come to the same answers if we're giving analysis that drives a business decision. We want it to be a clear way forward. So we looked at this and said, what can we do to kind of help this data process? How can we make things better? We decided the way forward would be to bring all of this data together into one place. For us, that was Google BigQuery. We chose BigQuery as big Google Analytics users. It was a logical next step for us to use the kind of one-click Google Analytics importer into BigQuery. And then once we had that initial big source of data there it made sense to add everything else to that. So today, what Looker gives us is a platform to sit on top of all of that data in BigQuery. Obviously, if we open BigQuery out to the business, it's a technical interface and our business users would struggle getting insight from it. Looker critically gives us that semantic layer where we can define a business-wide dictionary of dimensions and measures for M&M. And it means our business users can get stuck into getting value from building reports, dashboards, running queries without having to worry about whether they're using the right definition of revenue or the right definition of a particular product type. So we centrally manage all of that as a small team. And then that really frees up all this data then to be used by anyone across the business. So now we come on to what we're all here today to talk about, which is real-time alerting. So we have an environment today where all of our business data is collected in BigQuery in real time. So every day we're collecting millions and millions of rows of interaction data on how our customers are moving through our website. My team are always looking for ways to leverage this data for business value. One project that was proposed by our e-commerce team was, can we use this information to alert on the performance of the website in real time, to leverage this data to show if there are any issues, if our customers are experiencing any pain points, anything that's stopping our customers making a purchase or getting the best experience possible. When we're collecting such a huge amount of data, that's really hard to do in real time. So we spoke to Datatonic, we outlined this problem, and we asked for their help in giving real-time alerting to the business so that we could react more proactively to any bad experiences our customers were having and fix them before they became big issues.
Thanks, Ben. So that brings us to the problem. So let's talk a little bit around that. The ask itself was we needed to deal with live data, so streaming data. We needed to look at some key metrics, so things like adds to the basket, orders that are processed, whether people are actually hitting the order screen itself. So lots of key gateways that we need to just check, and we need to be checking that on a periodic basis very, very quickly. So ideally, we were checking this every 5 minutes. So I had to think about a number of things. One of those was, what value do we expect? And we also need to take into account seasonality, and not just seasonality over days. So, for example, Christmas period versus the summer period. We also need to think about time of day. So at what hour would we expect that value to be? So what we needed to do was allow a business user to set up an alert based on a key performance metric. So we're going to be looking at the demo today, which we built out to show a replica of what we built, and we're going to be using a count of orders. So the key metric would be what my count of order should look like, and if it doesn't look like that, we need to send an alert out. But that number that we need to, what we expect, needs to change throughout the day. This isn't a hard-coded number that we need. If we expect 2 orders to be coming in at midnight, but actually by the time we get to midday, we would have expected that day's worth of orders to be 2,000. We need to account for that. So every 5 minutes, we're checking what the orders should be for that day up to that point in time. So 2,000 orders up till midday. By the time we get to 1 o'clock, it should be 2,100 orders. And we need to check that we're hitting those metrics and we're not far off. If we happen to be quite substantially away from those metrics, either up or down, then we want to be sending an alert. And the way that we do that is we look at weighted averages. So we look at what the value was at the same time yesterday, and we can also look at it same time, same day last week, and also same time, same day last year. And that gives us that seasonality trend. We can look back and see what previous values were and make an assumption on how far away we should be from those. And we can also tweak the sensitivities of those. So we can put more emphasis on the value yesterday compared to the value last year. You could also flip it on its side and do a more predictive approach. So we also put in the ability, if you wanted to select a linear regression model which would predict what your value should be. And if you're quite substantially away from that, then again, it will alert. So the user is able to set these alerts up themselves. So they can say, give me an alert on order count. I want to check this every 5 minutes of the day. And I want to use either weighted averages or a linear regression model in order to predict. And I'm going to tweak my sensitivities and my numbers based on a couple of dials. So for the end user, very easy to do. They can set it up themselves without anyone needing to do it. But the complication, of course, comes in how you model it underneath. And that's where the hard work is. But luckily, Looker gives you some good tooling to do that. So let's just have a very quick look at the tech stack involved. Bit of a deep dive into that. So the components are, we have BigQuery, and BigQuery is a warehouse where, as Ben said, all of our data is, and that's where all the live streaming data is going in. Then we have Looker, and only other thing we need to do here is just use LookML. That's it. And then once the modeling is done, we're actually using Looker's scheduler in order to send the alerts out. So that's what the end user sees. They see the explore and then the scheduling features, which they can then set up. So that's it from a component perspective. So very simple. We don't really need to bring in anything else outside. We're not fiddling with the APIs. We're just writing pure LookML, and there's nothing we need to do in the warehouse either because the streaming data has already been set up. So we're just popping Looker on top. Okay, so when the user first enters into Looker, we expect them to come into an explore. So the user will actually set their alerts up through an explore menu. So that's the experience that we've created for them. Now you'll see in this particular explore, we have a number of options. Most of these you don't actually need to show your user, but for demo purposes, so I can show you how everything's working, I've basically allowed all of the dimensions and measures that we need for the demo for you to understand how it works. So the user comes in and they see you have this reference value here, and we have a time range. So the very first reference value is, as I explained, we've set up either a weighted average or a linear regression to be used to compare your current values against. So the user might decide they want a weighted average, and they want to check this 5 minutes, every 15 minutes, 20, 30, or hourly. So we've decided on these timescales, so you can decide yourself. I wouldn't recommend anything below 5 minutes, but anything above is perfectly doable. And then they just bring in their metric name that they would like, such as order count. And that basically is all they have to do. They just have to say, this is the metric name I want, this is the reference value, and this is the time range. But there are a number of other options that they can bring in as well. So let's just jump into an example. Here I have a look saved, and what this is doing is it's showing me order count. The black is the order count for that particular time, and I'm just looking at a particular day here just to kind of give you an example. So you can see here at 2 o'clock the order was 17, and then at 2 o'clock the reference value was 18.33. So our weighted average from same day, same time yesterday, last week, and last year is 18.3, and our today's value is 17. That's not too different from what we expect, so there's no trigger, there's no alert sent. Whereas you can see at 1 o'clock, there is quite a substantial difference, 29 being the current value and 18.66 being the reference. And you can see there was a trigger. So there would have been an email sent to the end user to say, hey, this value is quite a bit different to what we would expect. Maybe you should come in and have a look at this. So in this case, we would alert operations to say, we've got some pretty big orders coming through on that hour. Are you able to take these on? If I flip to the filters, you'll see this is all of the metrics that we have to play with. So we've selected order count as our KPI, weighted average as our reference, and then we have a sensitivity here as well. This is actually how many standard deviations away from the mean. So when we're using weighted average, that's what our sensitivity is doing. If we flipped a linear regression, then sensitivity would be set up in a different way. But for this particular use case, using weighted average, I could say, send me an alert if it's 1 standard deviation away from the weighted average, or I can say, send me an alert if it's 3 standard deviations away from the average. 3 is typically what you would do because it is quite anything in above 3 standard deviations away is generally a statistical significance, so it tends to be quite extreme. So something's gone very wrong or something's gone very, very right for you. But for this example, we set it at 1 just so you can see some triggers. We set this as an hourly time interval, which is why you can see the graph is set at hourly. And then these are the weights that we're going to apply for last week, last year, and yesterday. So a 1 means I'm going to be applying equal weighting, but I could also apply a 50% rating to that, 25 to that, and then a 25 to that. So you can kind of decide on how you want your weightings to be applied on creating that weighted average mean. If we have a look at the data, you can see here, this is generically what we're using. The end user doesn't need to see this. They don't need to select this and create this as a look. This is more just for us to show you how it's working underneath. But you can see we're looking at the yesterday's value, last week's value, last year's value, and then we're computing a weighted average on that and then comparing it. The way the user would use this is they go into the Explore and they pick through all these filters what they want. And they kind of pick on the metrics they require, and they can have a browse of the numbers as they see. But if they actually want to set an alert up, actually all they have to do is go into the Explore or a look that you have set up for them, and they just click on this up here, and they click schedule. That's it. So if I click create schedule, I'm going to send an email to myself. I'm going to send it to me. And I'm going to format it as a data table or a visualization. I'm going to send the visualization. It's going to be a repeating interval. It's going to be daily. And this is where things get a little bit different to how you would usually use a schedule. You need to send this every day at the same time interval that you would for the time interval here. So if I send this as every hour, I need to set this to be scheduled every hour as well. And if I set this every 5 minutes, I need to then schedule this every 5 minutes. The reason we do that is the schedule is actually running a query and checking the same time period. So every hour, it's running that query to check these numbers. So if there is a trigger there, the schedule goes, oh, okay, there's some data here to return. I'm going to send this across. So you actually set all your weightings and everything up here. You don't do it in the Explore menu, you do it here in the scheduling menu. And the key thing here is you only schedule this if there are results. So if there is a trigger, you want to set a filter up in your look to say filter only when trigger is yes, and therefore it's going to return results in the look. And if I just click on cancel for a second, and I'm just going to go into Explore, what this would look like is alert triggered. And you need to filter that to yes. And then what happens is it will only ever return data when that alert is triggered. So we would only return these 2 rows. If there is nothing triggered, then it's not going to return anything, and therefore it's not going to send you an email. So that's how we get around whether an email is sent to you or not. And of course, you can set all sorts of other filters up here on top of that. So you can add whatever you want to this model. So that's pretty cool. If I just flip back to the schedule again. The beauty of this is I can set as many schedules as I want. So I can call this, we only want to see if there's a results. Call this alert example 1, and I could save that, and then I could create alert example 2, and so forth, or I can say this is Jamie's alert. And the cool thing about this is they're all here in this Explore. So you can come back to this screen and you can manage your alerts from the Look itself or from the Explore menu. So that's really cool. You don't have to go to the admin menu and manage your alerts there. End users can come in and manage them from this page. So that's going to probably send me lots of emails now, so I'll have to go back and correct that later. But that gives you a good example of how that works from a user perspective. If we just look at this visualization again, this is me just showing you where we can see the alerts triggered. And if I bring in last week, yesterday, and last year's value, you can clearly see how these make up that reference value here in the middle. So it's a combination of all of these values which give us this nice weighted average. Okay, so let's have a look underneath at the model itself. So I'm going to flip over to the project, and you can see I'm in develop mode here because we're going to be playing around. Have a look on the left here in the file browser, and you'll see we have 5 files. So we've split this out into 5 separate files. No reason why you can't do it all in one, but this is a good way of layering your code. And then we have one model here and one Explore. So this is the Explore for the alerting. And you can see here we have some always filters in here based on the time range to bring in, and of course that reference value. So you need to pick whether you're bringing in the linear regression or the weighted average. So the Explore itself is pretty simple, but let's cut this down into sections first. So the very first section is going to be parameters. So you saw we had all of those little buttons for the user to play with. Set the weight yesterday, weight last week, weight last year, and we have some default values for those. And we want someone to also set the sensitivity. So that'd be X number of deviations away from the mean. And the default for that's going to be 3, because that's our recommendation. And then we also have a parameter for the time range. So we're allowing the user to set alerts up in 5 different time ranges. And then we also have to have a selection for them to pick we're calling this the metric names, but this is basically the KPIs. So in this demo piece of code, I've only got one, and that's order count, but you can have anything you want there. And the very last one is, of course, the reference value itself. This is quite important, actually, and you can see we've got type unquoted here as well, and type unquoted for metric name, and that's because we're actually going to be passing these values through into the code elsewhere. So we need to be passing them through without any quotations. So that's the first thing, and we hold this in a view object by itself, and as you can see, there's nothing else happening with it. So we actually extend this code elsewhere. The second thing is the time dimensions. So as you can probably imagine, there's a lot of sophistication underneath on how we actually calculate the point in time that we're looking at the data. And again, this is just holding a load of dimensions as objects. We're not putting a SQL table here. We're not bringing in our data in any way, shape, or form. We're just defining the time objects, which we can then use as a template in other areas of our code. So you could use this not just for this alerting, but you could use this elsewhere. So we need a dimension for 5 minutes, 15, 20, 30, and hourly. And we need that for the current timestamp, so the current point in time. And you can see we're utilizing Looker's type metric there to get that 5-minute interval. We've done that so you don't have to mess around with database dialects. So this could be used for any dialect you have. We then, I just do that for a second. We then have the same for looking at 5 minutes from now. So what was the time 5 minutes from now? 5 minutes before, 30 minutes before, 15 minutes before. So that's a requirement that we need as well. And we then do the same for our actual data itself. So we also need to figure out that 5-minute time interval or that hourly time interval for the timestamp in the data that we're actually looking at. Now, we reference table here because we don't actually know what the SQL table is going to be at this point, so we're just doing a generic substitution operator. But the actual timestamp field that we're going to be using, we're going to call it time. So wherever your data is coming from, we're going to rename it to that in a derived table, which you will see in a bit. So if we just unfold all of that code again, you'll see I'm then setting up various different dimensions here to work out whether we're using the hourly or 5-minute dimensions and whatnot. So this is code which will open source, so you can go through this in a bit more detail yourself. But the takeaway here is we're just setting up all of the different time dimensions we need, and we're driving that with the parameter selection which the users will use. So that would be the time range parameter that they select. And we also have a couple of dimensions down here which will be used as flags. So is yesterday, is last week, is last year. And those will be flags which will come in against the rows of your data, so we can identify if that row of data is yesterday's date, or whether that row of data happens to be last year. Because of course that's dynamic. That changes every time we run the query. A row of data could be yesterday and then suddenly it's last week when we look at it a week later. So we have to do that in a dynamic way, and that's why those dimensions exist. And then the very third section here, before we start to actually tie in our data, is that we then have our measures and our dims for the weighted average. And you would also have another view file if you were doing the linear regression, which I'm not going to go into because it's using BigQuery machine learning, which is a whole nother topic, and not everyone also uses BigQuery. So the takeaway here is you will have a view for each way that you want to calculate your reference point. So we're extending the time dimensions in here. So they're coming into this weighted average file. And then we're working out what our today's value is by looking at the metric name itself. So the metric name will decide on what field we're going to be pulling through. And then we have that filter, that is today filter, to actually then pinpoint the row of data that's today's value. And we do the same for all of the periods that we're looking at. And then right at the bottom, you'll see here, we have the weighted average. I just zoom in a bit there. We have this weighted average, and that is our calculation for actually working out the weighted average whilst taking into account the sensitivities that people might be wanting to use. Okay, so we need to now pull this all together. So you can see I'm in the metrics file, and what we're actually doing here is we're creating a KPI. So we have our order count here. That's our KPI, and we're looking at that on an hourly basis. Obviously, we want to look at that as well on a 5-minute, 15, and 30. So at most, we need the hourly timestamp, and we're pulling this through as its own derived table because that's all I need. I just need the order count and the timestamp. And you would do this for each KPI that you want to have an alert on. Then you'll see we have an Explore here called the Alerting Metrics Explore. And we're actually joining in the parameters in order to make them available. And we're also joining in the linear regression metrics as well, because that's done very differently in doing linear models. We're not going to cover that off. And the Explore alerting metrics, we're actually exposing that view here in this Explore. And what this is doing is it's extending our weighted average. And so all of those dimensions in the weighted average file and the time dimensions file will flow through into this view. And then we're using, just navigate to it a bit better here so you can see, we're then using the metric name parameter to decide on what table we're actually hitting. So if someone selects order count, we're going to hit that order count derived table that we created up here. And we're also going to extract time from that timestamp that we have in there. And we're going to add in a 15-minute interval there. So we're actually filtering on the data for each day to match that specific point in time for the day as well. So that's quite important to make sure that we're matching those time periods. Now this is an inefficient piece of code. I've left this in here for demo purposes. It's easier to run through. Ideally, you would write this in a different way where we're not doing a select all, and you're also passing through whatever dialect you're using. You need to also pass through things like partition filtering and use of clustering and stuff. So this will very much change the look depending on your database dialect and how your data is actually set up. So that's quite important. And then the very last thing we do is we actually expose this as a derived table itself. So we have an explore source for that alerting metrics, as you saw here. And that explore source then goes into a derived table. And the reason we do this is we just want to dimensionalize all of these measures. And we also need to bind those parameters together. So those parameters need to be binded to themselves so that they can operate in all of those subqueries. So that's quite an important step to do. And this is also where the magic happens with the alerting itself. So this is actually where we then define the alert is triggered measure, which is where we're taking the reference value and we're basically minusing off today's value, the mean, and then comparing that to the mean less the standard deviation times the sensitivity, which is quite important. And we're also defining the threshold metric there as well. And we also have some what you call time window filters. That's quite important too. We can give the ability for the user to decide whether they're looking at the current time window. So for example, it's 1 minute to 5, and we're looking every 5 minutes. The current time window would be 4:55 to 5. Or are we looking at the previous time window, which would be 4:50 to 4:55? So that's quite important to note as well. So that's the code. Can get a little complicated at the end there. We're going to open source this so you can go through and try it out yourself. You don't need to change anything from number 1 to 3. Where you start adding in your own metrics or information is going to be file 4 and file 5, and you can customize that to how you want. So let's just jump back to the slides and we'll have a little talk about lessons learned.
Thanks, Jeremy. It's great to look back now at all the hard work that went into this project and see the kind of value we're getting from it. So in terms of what this project has been able to do for the business, it's obviously given us that real-time reporting system that we wanted. And we're able to alert on any issues or any friction that our customers are experiencing on the website in almost real time. And the value that adds to us, especially during a period like our Christmas trading period or our peak trading period, where literally every hour we're taking thousands of orders. So any kind of small issue that lasts even half an hour can cost the business a considerable amount of money. So being able to react to them really quickly has really been invaluable. And I think leveraging the power of Looker has been amazing too for this project. So without having to build anything or spend a lot of time developing our own solution, we've been able to leverage the tools within Looker, like the email alerting, and just being able to tackle this with LookML has been really great. So we're able to build on what we've got without having to kind of reinvent a whole solution. So well done.
So the final takeaways will be, it's quite a sophisticated solution, but for the end user, quite a nice experience because they don't see any of the modeling underneath. They just have that nice explore menu to manage their alerts and create them. It's also a near-time warning system, and we're not having to use any other tools outside of what M&M Direct already had. So we worked with what we had. We had Looker. Let's make it in Looker. Let's not try and create any other plugging systems together. We're using lots of different services. There's just no need. And of course, it's customizable exactly to how you require it. Your analysts can set it up. It doesn't require a data engineer to go and do. And it allows you to action on your operations. So in this case, we're monitoring operations and we're getting insight into what's going on very quickly, whereas other tools will actually have a larger lag to actually notifying you on what's going on. So with that, I just want to say thank you. If you want more information, you can contact either me or Ben. You can contact us on Twitter or LinkedIn or through our emails. You can visit our website to find out more. There's lots of technical blogs on there as well. I did mention BQML with a Looker wrapper. That is a pretty good solution to pair with this alerting block, which you can view on how to do that on our blog posts on datatonic.com. And this code for which I've just shown you through will be posted on the community, so please do look out for that community post. And I hope you enjoy the rest of your day and the rest of Join.